Great. This is, most of you have been to the forum before, so you're familiar with lightning round talks, but my lightning talk about lightning round talks is that these are largely next generation students who either have posters or would like to inform you about their science and where they're from. They have 60 seconds to tell you all of that and hopefully can advertise for their posters. There are no visuals, there are no questions, and if you do have questions, then I encourage you to hunt them down over the course of the next 3 days to ask them. So at 60 seconds, you'll probably hear a weird little noise come from my phone, and that'll let you know that you're going over time, and then we'll get the big red cane and yank you off the stage. So with that, we're going to go ahead and get started, and we'll just go rapid fire. As soon as one is done, the next one goes. Come on up.
Good morning. My name's Ben Hawkman. I go to school just up the road at Stanford, and I've been working for the past few years on a project in collaboration with JPL on developing a new type of robotic platform for exploring small solar system bodies. These are bodies that have largely been inaccessible to controlled mobility platforms like MSL. The idea is these bodies are so geologically diverse that we really have the need to explore different regions on the surface. So what we've developed is a low-cost, minimalistic rover we call Hedgehog, and it's basically a small little cube with 3 internal reaction wheels that it uses to hop and tumble across the surface. And so if you're interested in hearing more about how we actually do that, how we control these flywheels, how we do it in an autonomous way, in line with the workshop this Friday, we've been doing a lot of work on the autonomy aspects, or if you just want to hear about the types of new science that this could enable, come talk to me. My poster's 75, and I'll be here this evening. Thanks.
Good morning. I'm Raul Ghani, and I'm a graduate student at USC studying astronautical engineering. I have a poster here in the back room that talks about lava tubes and how to use them, how to map them for exploration purposes, and how to use them for settlements, for colonizing Moon and Mars. So if you'd like to learn more about that, please come by poster 59. I'll be there at 5:30 p.m.
Hello, we are student researchers from Comac High School, New York, and we placed first in the Xmas competition. This is Dena Levine, Pragdi Muthu Kumar, and I'm KarenAbruzzo. We are poster 49. For our project, we mapped locations of water ice on the moon using economic, mineral, and topographic data. We looked for locations that had low enough slopes for a spacecraft to land and had high abundances of hydrogen and oxygen. We also did an economic feasibility test to see if it would be possible for a mining mission on the moon.
We created the maps using ArcGIS. We used Lunar Reconnaissance Orbiter topography maps and Lunar Prospector elemental data. We saw that the North and South poles had the highest abundances of both hydrogen and oxygen. We overlaid hydrogen and oxygen layers and assumed that the highest abundances of hydrogen and oxygen would have the water ice deposits located there.
In addition to that, can you hear me? Okay. In addition to that, we also researched United States-built rockets in order to determine which model would possibly benefit most from a lunar mining mission in order to help with future space travel. And we think that lunar ice mining is very potentially important because it could support both deep space travel by a potential source of rocket fuel and also a potential scientific lunar base, as the ice could be used as both a coolant or for breathable oxygen. Thank you.
Aloha mai kako. My name is Nicolette Thomas. I am a senior undergraduate at the University of Hawaii at Hilo. The research that I'm going to be sharing with you today is about the engineering of plants to contain a perchlorate-reducing metabolic pathway typically found in bacteria. The goal of this research is to assist in solving the problem of perchlorate in Martian regolith as it pertains to future human explorations of Mars. My funding for this project was initially provided by the NASA Hawaii Space Grant Consortium, continues to be funded by the University of Hawaii at Hilo Seed Grant. My poster number is 64. I will be there between 5:30 and 6:30 p.m. today. I'd be more than happy if you could join me. Poster 64, but I'm also doing a internship here this summer, so I will be in building 239, floor 2, if you have any more questions and you can't come see me tonight. Mahalo.
Hi, my name is Dena Phillips from the University of Alabama in Huntsville, and my research is about the analysis of rediscovered Apollo seismic data from Apollo 17 and evidence for events associated with sunrise. Essentially, Apollo 12 through 16 has been extensively analyzed for the seismic data content, but Apollo 17 has not. We are analyzing this data from 1976 to 1977, categorizing the seismic waveforms, and correlating these events both temporally and directionally. We have found evidence for events associated with sunrise for both sunrise and sunset, and these are thermally induced events. Again, my name is Dena Phillips, poster number 37, and I will be there this evening about 5:30.
Hello, everyone. My name is Ben Melankoff. I'm an undergraduate aerospace engineering major at the University of Colorado at Boulder. I also work at the Center for Astrophysics and Space Astronomy under Dr. Jack Burns, where we are researching applications of low latency surface telerobotics for missions to the moon. So in particular, we are researching some limitations associated with this type of exploration strategy. And in particular, we are looking at the minimum frame rate, and the reason why we're looking at this is because the bandwidth available varies depending on line of sight between spacecraft and the the rovers that are being controlled. So we set up an experiment to identify this minimum frame rate, and we think we found a pretty interesting result. So if you'd like to find out more, just please come visit us at poster 76. And then also my colleague Matt is going to be talking more about some additional experiments that we did. Thank you.
Hello, everyone. My name is Matthew Speidel. As Ben said, I work with him, with Jack Burns, Center for Astrophysics Space Astronomy at University of Colorado Boulder. I'm studying electrical engineering. He went over a brief description of what we're doing. Specifically, I'm going to talk about what we did this summer. Our experiment this summer investigated low latency or latency conditions for telerobotics. For example, the Curiosity rover operates at a fairly high latency condition, average 20 minutes round trip time. Our experiment investigated specifically 2.6 seconds. This is significant because it is the latency condition from Earth to lunar far side. There are a lot of thoughts, assumptions that operating at that latency condition isn't really much different than operating low latency, so we decided to investigate this. If you want to learn more about this, come check out poster 78. If you need more incentive, we do have our rover with us so you can see firsthand the pretty astonishing difference between 0.3 seconds low latency and 2.6 seconds. Again, my name is Matthew Speidel. Come check out poster 78. Thank you.
Hi, my name is Vidal. I just graduated from high school in the spring. I'll be attending Iowa State University this fall, where I plan on majoring in astronomy and geology. I'm presenting a poster here called Benefit of Involving Young Students in NASA Fieldwork. 2 years ago, I joined the Finesse research team in their field deployment, and I got to experience authentic hands-on scientific research, and this completely changed my perception of science and career goals. And I think it's so important for young students like me to have mentors like you. So I would like to start that discussion and help you guys understand what is helpful as a student to see and what we're exposed to in the classroom and how that's completely different than what I was exposed to in my experiences with finesse. Since then, I've worked with finesse and I've worked with basalt too, so fieldwork is my jam. The skies really interest me so much that I started flying planes in my free time. My poster is number 46. I'll be there from 5:30 to 6 today, and I hope to see you there and discuss more about how we can get more young students like me involved in scientific research. Hope to see you there.
My name is Erica Jowan. I'm a grad student at Brown University, and I have a poster today studying lunar volcanism. Instead of talking about that, though, I would like to talk about something completely different, which is the framework in which we discuss the future of exploration. Often we turn to the past, specifically the era of European colonial exploration, as has often been discussed by Dan Britt, who I think just left the room. This was an era of discovery, of inspiration, but it was also an era of conquest, of extraction, exploitation of natural resources, as well as human resources and environmental destruction. So I would really encourage all of us here at the Exploration Science Forum to make sure that we consider both the positive and the negative aspects of our past history of exploration to ensure that we don't repeat the mistakes of the past when we're exploring new worlds and extracting resources there. Doing so will ensure a more beneficial and sustainable future of planetary exploration. Thank you.
My name's Alessandra Springman. I'm a graduate student at the University of Arizona. Most of you know me as Sandy. I'm going to be presenting poster 24 on some comets that are passing close by Earth. So between now and 2019, there are 3 comets passing within about 55 lunar distances of Earth. This is a great opportunity to study comets at close range to understand their inner coma properties, dust grain environment, especially for considering future sample return. After 2019, there are no comets coming this close to Earth, unless a long period comet comes along, until about 2038 or 2048. So I don't know what most of you are going to be doing in 2038 or 2048. So this is the last opportunity to study comets at close range, figure out what's going on in them, and use this information for future missions, and planning. And so we're creating a really consistent data set taken in a variety of wavelengths, ranging from visible to infrared to radar, to get a full picture of these comets and to create a consistent data set for future analysis. So if you'd like to stop by, I'll be at poster 24, and I'd be happy to answer your questions. Also, I'm one of the Loon GradCon organizers, the Lunar and Small Bodies Graduate Conference. So if you have any questions about Loon GradCon, if you'd like to participate in the future, get involved, I'd be happy to answer those questions too. Thank you so much.
Hi everyone, I'm Zach Levine, and I work at the Impact Dust Accelerator at the University of Colorado. I study mass spectroscopy of the ejecta from dust impacts into ice targets. This is important for the long-term chemical evolution of airless icy bodies throughout the solar system. I think one of the most interesting recent results that we've had was by doping pure water ice with arginine, a simple amino acid. And by looking at the mass spectra of the ejecta from dust impacts into this ice, we were actually able to resolve that arginine. And this would be important for the upcoming Suda mission, which is part of the Europa Clipper. Because if there are amino acids in the ice of Europa, this means that Suda should be able to pick them out and tell us. So yeah, I have a poster. It's about ice, so guys, that means it's cool, all right? We'll have excellent science, painful puns. It's gonna be today and tomorrow, 5 o'clock. And again, I'm Zach Ulivari from the University of Colorado. It's gonna be poster number 12. And also, I'm also a Loon GradCon organizer, so feel free to ask me about questions as well. Thanks, guys.
Good job, everyone. And I want to tell you that most of those students, almost all of them, I believe, were at the 7 a.m. breakfast with me this morning, where we gave them tips on how to do that. So I think they get a lot of praise for showing up and doing this and coming at 7 a.m. So we are now going to break for lunch, and you've got a good long lunch, and we'll see you back at 1:45 in this room. And so have a great time. Oh, let's thank all our speakers for the morning, please.